Okay, so this is the homework for the section called Analyzing Graphs of Functions. So we're basically going to focus on two tasks. One is to find the zeros of the function. And we'll do this a lot more in chapter 2, but at this point we're just going to talk about how you do this, and then we'll also look at whether functions are odd, even, or neither. So let's add a page here and look at these different functions. So typically, to find the zeros of functions are when the values of x where the function equals 0. So you would take the function value and set it equal to 0, and then figure out what values of x that's going to happen at. And for quadratic equations, there's either two zeros, two values of x where the function goes to 0, or there are none. And we'll talk about more about that when we get further along. Now this one is just really an exercise in trying to factor this thing, and it's not a simple factorization, but it's probably using, I guess you could say, it's probably using something like grouping, or maybe just by observation. So if I were to break this up into two factors, most likely this would be 2x and this would be x, just because they're not going to give you problems involving square roots and things like that, or other non-integer results. And because I have a negative sign here, I know that one of these has to be negative, one has to be positive. And because this middle term is negative, that means that the bigger number has to be the larger number that multiplied to two numbers multiplied together have to the larger number has to go with the negative part. So you think about 30, you think about the factors of 30, which are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So those are it. Now usually they're not the extremes, so that's probably not going to be that, especially when this number is not too big. So we might try this one first. And this could either be the 5 or the 6, because I've got this multiplier factor of 2, so it's maybe not quite as obvious. So let's just try it. Put 6 and 5 there, and we'll flip it around. So if I make this positive, I'll have 2x times negative 6, which is negative 12. And then I'll have 5x. So 5x minus 12 is negative 7. What? How about that? Just got the right answer. If I guessed wrong initially, I wouldn't get, when I multiply this out using FOIL, I wouldn't get the right answer. So now that it's factored, this product of these two terms is 0 when either one is 0. Now they're both not going to be 0 at the same time. So what we can say is that the zeros of this quadratic function happen when either this is 0, the x values, so this is 0, or x values, so that's 0. So you just set each factor. Okay, so what we're going to do is we're going to subtract 5 from both sides, and then we divide both sides by 2, so you get negative 5 halves. And over here you add 6 to both sides, so you get that. And so the final answer here is going to be, well, actually that is, the zeros are going to be negative 5 halves, comma 0, and 6, comma 0. Now we haven't talked about rational functions, and we'll cover this more in detail in the second chapter, but the rational functions are 0 when the numerator of the rational function is 0. So we're going to just have to have that 0. The denominator has no impact on zeros. The denominator has an impact on things called vertical asymptotes. So again, this is one we probably can do by observation, just because I don't think they put it in here. And so then you look at the factors of 14, which are 1 and 14, 2 and 7, and that's it. And you'll say, oh, 2 plus 7 equals 9. So that makes sense. So if I put a 2 here and a 7 there, but they add together to be -9, so these both have to be negative. And that works out well because the product has to be positive 14. So negative times negative is positive, but when you do the inner and outer, you're going to get -9. So again, for this function to be 0, the numerator to be 0, each factor has to be 0, so you set those equal to 0, and you get x equals 2 and x equals 7. Now this terminology, these are factors, these are zeros, so the factors are always negative. I guess, here you see -2, here you see +2, here you see -7. So a lot of times people think the 0 is -7, but that's not true. The 0 is when the values of x that cause this part to go to 0. Okay, third one you might be intimidated by, but it's one of those that if you think about it, you might be able to figure it out. So notice that this number is 6 times that number, and this number is, well, -6 times that number. So I think what you could do is you could take the first two terms, group those together, and take the last two terms, group those together. Now if I factored out a -4x squared out of the first expression, I get -6 plus -x plus 6. Another way of doing this is I could have factored out a +4x squared. So I have +4x squared times x minus 6, and I could factor out a -1 out of here, x minus 6. And so since both of these are multiplied by x minus 6, I can then group those two terms together, and I get that. Now, again, to have the resultant be 0, that's what we're trying to do here. The values of x where this thing goes to 0. 4x squared minus 1 has to equal 0, and x minus 6 equals 0. Well, this one, x minus 6 equals 0. So that one is pretty easy. We've done that before. X equals 6. Here, what you do is you'd add 1 to both sides, divide by 4, take the square root. Now the key thing here, and this is what people forget, is you got to take plus or minus the square root of 1/4, which is going to be plus or minus 1/2. So there are three solutions. There's x equals 6, x equals positive 1/2, and x equals negative 1/2. And that makes sense. You need 3. For a third of a polynomial, you have to have 3 roots, 3 zeros, real zeros, or 1 real zero. You can't have even numbers, 2, 4, whatever. Okay, the next one is a square root, and we can't have x such that we get a negative argument, but we know that the function is equal to 0 when the argument of the square root is 0. The only way you can get 0 is take the square root of 0. So all we have to do is just set the argument equal to 0 and find out the values of x where this occur. So you get 3x equal to -6, x equals -6 divided by 3, x equals -2. And you can see that works. If I plug back in, 3 times negative 2 is negative 6 plus 6, 0. So in this case, we just have 1, 0. And you can, for square roots, you can have 1, 0. If there's nothing added on here, it's just a square to something, you're going to have 1, 0, not 2, 0. So quadratic equations, you have 2 or 0. For a rational function, depends on the order of the numerator. Third order, you can either have 1 or 3 or 5. For third order, you'd have 1 or 3. Okay, and then the question of whether something is odd or even. So just as a reminder, y equals x squared is even, which means that if you go either side of the origin, that you're going to have symmetry. And the same thing, whereas for odd, what happens is, say, y equals x cubed. What happens there is if you go to negative x, you get a negative result. But it is symmetric. There's some symmetry around the y-axis. So if you look at the book, let's pull out your book and look in there. This is section 3, I think. No, section 4. So there's a test. And it says functions even if for each x in the domain f of minus x equals f of x. And it's odd if f of minus x equals minus f of x. So what you do is you're going to, well, we know what f of x is. So if you do f of minus x, you're going to get negative x to the 6th minus 2 negative x squared plus 3. And because these are even powers, when you take the even power of a negative number, it becomes positive. Same over here, even power becomes positive. And you can see that f of x equals f of negative x. So it's an even, this is an even function. Let's try this one. That was number 5. So let's try f of minus x is going to be equal to minus x times the square root. So for x, I'm putting in negative x. 1 minus negative x squared. So the term out front doesn't change, but the one inside the parentheses, negative x squared, is going to be positive x squared. So what we see here is f of negative x is actually equal to negative f of x. Because I've got negative sign here, I don't have a negative sign. So this one is an example of an odd function. Now if I had something up here like x to the 6th minus 5x, some x to the 5th, then it wouldn't be either even or odd. I think that's true. Okay, so that's it. Okay, so let's go ahead and do some more problems which involve finding the zeros of the function. Now remember, the zeros are the x-intercepts. They're the same thing. So we use the same procedure as before. We set y equal to 0 or f of x equal to 0, and we solve for the values of x where that happens. So we've got, the first one is a polynomial. Now one thing you should always do is look to see if there's something you can a common factor you can factor out. So you can see that every one of these is divisible by 3, so we can factor out a 3. And we have an x in each term, x cubed, x squared, x. So what we'd do is we'd factor out, now I'm not going to set it equal to 0 yet, so we're going to factor out the 3x. And what that leaves is x squared plus 7x plus 6. So if we multiply this out, we'll get back to where we started. Now it turns out this multiplier 3 doesn't affect the zeros at all. It just affects the magnitude of the values other than 0. Now if we factor out this common factor x, we may be able to continue factoring it. So now I'm going to set equal to 0. And you can factor that. What two numbers multiplied together equals 6? Well, there's two choices, 6 times 1 or 3 times 2. Which two add up to 7? 6 and 1. And because it's positive, positive 7 and positive 6, they're both going to be positive. So it'll be x plus 6, x plus 1. So let's just check that out. X squared, 6x, 1x, 7x, and 6. Okay. Now, so there are 3 zeros for this function. Now, sometimes people might say, well, I can just divide by x and get rid of it, but you don't want to divide by anything here. I guess you could divide by 3, but you don't want to divide by any variables. So the 3 solutions are going to be x equals 0 from this one, x equals negative 6 from here, and x equals negative 1 from there. So those are my zeros. Now it doesn't ask, I don't need to put them as a coordinate pair because the zeros are just the x values which cause the function to go to 0. I wouldn't mark off if you put them as coordinates, but you don't necessarily need to do that. Now in the second chapter we'll learn about how you factor third order polynomials if this last term is a constant, where you can't factor out x. Okay, next one, square root term. So again, set the function equal to 0. If you remember back earlier sections, if I tried to solve for x, and the first step would be to move this constant to the other side, make it positive. If this were a negative number, then I just stop and say there are no x-intercepts, there are no zeros. But in this case, it's positive, so that's good. Divide both sides by 2. So I get 2 is equal to the square root of x plus 2. And then I would square it. To get that. And then I would subtract 2 from both sides. So I get x equals 2. And one of the things we should always do, sometimes we don't because we're lazy, is to plug it back in and make sure it's true or not. So if you plug x equals 2 in here, you'll get 2 plus 2, which is 4. The square root of 4 is 2. So this whole thing becomes 2 after you simplified it. 2 times 2 is 4. 4 minus 4 is 0. Okay. Now, if I got to this point and I had a negative number here, then there are no x-intercepts. Okay, problem number 9. What the tendency is a lot of times is to think, okay, I've got to just factor everything. But when you're talking about zeros, all you're concerned about is the numerator. So we just set the numerator equal to 0. Just like here, we set the whole function equal to 0 when it comes to a rational function. Then we just set the numerator equal to 0. So we get x equals 2 is the x-intercept. Now here you could get, if I factored that and I get zeros, I could get vertical asymptotes, which we'll talk about in chapter 2, but all we worried about now is just stick with the numerator when it comes to zeros. So here's the same kind of thing. We don't worry about the denominator. We just set the numerator equal to 0. See if we can factor this thing. And we can. because what two numbers multiplied together equal 15? Well, there's two choices, 1 times 15, 3 times 5. 3 plus 5 is 8, so it's going to be 3 and 5. And because that's negative, they both have to be negative. So you get negative 5, negative 3, so negative 5 times negative 3 is positive 15. And so the zeros are going to be x equals 5 and x equals 3. Again, the denominator has no impact on zeros, has impact on other stuff, which we'll learn more about in chapter 2. And the final problem is this absolute value thing. And actually, change that to there. Okay. Because I think the way this works is that what I just did there was it only had one x-intercept, which was would be at x equals 2. This is going to give us 2 of them. So okay, so what do we do? Set equal to 0. Now the question is, what do we do with the absolute value? Well, the way you do it is you do go 2 different paths. Let's see if this works out or not. One way is you just make everything positive. So we just take the absolute value signs off. So then you get 0 is 2x minus 4. 2x equals 4. So if this goes to the other side, it becomes positive. Divide both sides by 2, you get x equals 2. Okay, so that's one of them. Now, what's going to happen, it's been a long time since I've done absolute value, but you know, this thing is going to look probably something like this. It's facing upward because that's positive. And this always has to be greater than 0. So the minimum is at y equals negative 2. And this thing shifted somewhat, so it's going to be to the right here. So this is the one we found, the positive version. So I think what you do is you would put a negative sign in front of this term and set it equal to 0. See if that works out and gives the right answer. So you get negative 2x plus 2 minus 2. These cancel out, so you get 0 is equal to negative 2x, or x equals 0. And that makes sense in some ways because, you know, this thing is going to be centered here. We'll find out later why this is true. This is x equals 1. This is x equals 2 from the first part of the problem. So just from symmetry, this is going to be x equals 0. So it looks like that's the right way to do it. So when you have an absolute value, you have 2 solutions if you have any. If you were up here, then you wouldn't have any solutions. But if you're below the x-axis, then you're going to have 2 solutions for x-intercepts. Now what would happen? How would you end up with this scenario? Well, if this were positive, because if you move this to the side, it becomes negative, and there's no way you can get an absolute value of something and be negative. So anyway, so one solution is to take the positive of this and solve, and the second way is to take the negative of this and solve for x. In this case, it just turned out that x equals 0. So, but if you had, you know, if we shifted over a little bit further, we would, let's just do that for the heck of it here. The problem's done, but if we had, f of x equals the absolute value of, say, 2x minus 4 instead, minus 2. So, one solution would be to make this positive. So we just remove the absolute value signs. So we get 0 equals 2x minus 6, 2x equals 6, x equals 3. So that's the one solution. The second solution is take the negative of this. Like that. So you get negative 2x plus 4 minus 2 and so what happens now? There's negative 2x plus 2. 4 minus 2 is 2. Move that to the side, becomes negative 2. Divide by 2, you get x equals 1. Oh, this one's negative. They're both negative, so we're going to divide by negative 2. So you get x equals 1. And you see what this is just shifted over 1 unit in the x direction. So that is the right procedure. Okay, that's it.